This is one of my daily drivers, the 98 Honda CR-V. For this build I'm going to be swapping in a J32A and a K-Series all-wheel drive transmission out of a 2nd gen CR-V. I received the trans first and I'm just inspecting it to see if it needs any replacement parts. The upgrades that I'm going to do to the trans are adding a 6th gear and an LSD. Well, it looks okay. I don't know what the mileage is, but there's nothing alarming in here. I'm not going to actually install the 6th gear or LSD yet. I just want to take it apart and make sure I had all the right pieces to do the conversion. Right, bad news. When I first got the transmission, I already found there's a crack up in here, just on the inside. I set the plate, the adapter plate on it with the dowels in it. This dowel, well, basically the space between the dowels is about a 1/16 of an inch off. And since I already knew there's a crack here, I assume this one was good, and this one needed to be pushed out. So I took my hydraulic thing here, set it in here, and pushed this one out until it lined up with the hole, and the plate was able to sit. Only problem is, when I did that, the big crack just opened up. It was probably already had like a hairline fracture. I just couldn't see by eye. You see, I'd already marked the original crack I found up in here. So these all-wheel drive cases are rare enough that it's worth trying to save it. So I'm gonna leave this plate on, use a die grinder, bevel this out, and try to weld it. Try to save it. That's the bad news. Good news, J32 just arrived. Alright, I'm using the adapter plate to help me get everything clamped down in position for welding. There's not really a bolt around here to use, so I'm just using a ton of clamps. So now I'm gonna take my die grinder and put a huge bevel all the way through the crack on both sides and weld it. Alright, there's that. See how the welding goes. Alright, looks like it's going to be saved. I welded up both cracks, and on the inside I built up extra. Now that I fixed that, to cut a big piece out of it, right here. So the starter, J2K. Now it's on the bottom. So basically I gotta take out all that. There's that done. Alright, the last major thing I gotta do to the transmission is grind this down. I've got the trans back apart again. So I need to take this speedo drive gear off the stock diff as well as these 2 gears. But the bearings, I got new bearings for the new diff. Gotta clean up all this, it's kind of a mess in here. Got all the parts I need off the old diff, ready to go on the Wavetrac. Alright, almost done with the diff. Last thing to do is to measure, make sure the shim in here is still correct. Alright, clearance with the diff is good. Now I'm going to install the 6th gear. Okay, 6th gear is installed. Unfortunately, I was about to put the bearing back on, but you see this ball right here, it's damaged. So I gotta wait on another one of these, or a new one of these. Other than that, it's pretty much ready to go together. Alright, I got these springs for the shift mechanism. It's supposed to be a little bit stiffer, so the shifter will be a little bit harder to move side to side. I also got these parts, which on the thread that had all the 6-speed conversion parts listed, it had some of this stuff listed as maybes, so I just went ahead and bought them. It looks like the same part that's already in there, but I gotta take it apart anyway, so I'll find out. Also, another thing I forgot to order that I will be ordering is the upgraded springs for the ball detents. I took the shift mechanism apart and cleaned everything up and painted it. Because, well, first I noticed the grease in here was really old. So I was gonna have to take it apart anyway, so I just decided to clean everything up. So I'm gonna put it back together with these new springs. There it is. Since this piece, I ordered this and I didn't need it, I just put the new one on anyways. Alright, bearing finally came in. It's been about 2 weeks. It's finally done. We put the case on without the Honda bond. I just put the shift mechanism on and make sure it goes through all the gears. Other than that, it's ready for paint. Alright, it's finally done. Turned out okay with the paint. Now it's time to move on to finishing the engine. I got to swap out the pan, do the time belt water pump, all those seals, valve adjustment, and start looking into how the header is going to be designed. Alright, time belt's done, valves are adjusted, all new seals everywhere. Doing a final test fit of the transmission and the starter, which, yeah, see, it goes under the pan, that's why it needs a custom pan. And for the exhaust, I mean, normally the exhaust would run through here, but with the K-series transmission, it sits high, kind of high compared to this. So I'll be able to take the exhaust down and route it under here. Well, I've been screwing with it for hours and I finally got the flywheel spacer sorted out, you could say. So whenever, I mean, having a spacer like this on the flywheel, I had to check the run out, obviously. I mean, it's something you should do anyways, but especially in this situation. So when I bolted first thing I did was bolted the flywheel directly to the crank and measured the run out, and I was at 3 thousandths, which is about half the service limit is 6 thousandths, so it was well within the limit. Then the next thing I did is I installed it with the spacer, and I was well past twice the limit. But I could tell when I put the spacer on the crank and tried to fit it in the flywheel, it was too tight. I had to use a mallet to get it on. I could just tell that it wasn't machined correctly. It was just off a little bit. So I'll take this off and I'll show you what I did with it to get it fixed. Alright, so this part was far too tight to fit in the flywheel, and this bore was too tight to fit over the crank. Well, it would fit, but I had to hammer it on. So got a carbide burr in my drill press, and basically I just ran it and did this very light pressure. I just kept test fitting it until it actually fit by hand. Same thing with this. Then you can see this, there's like a satin finish on this now. When I got it, this was all just like kind of machine marks, kind of rough. What I actually did was took valve grinding compound and like on the flywheel, put it on here, stuck this in here, just did that until the whole surface was satin, so I knew it was actually flat, because it wasn't flat when I got it. And I did the same thing on the crank. Now it all fits. And now the runout's at 4 thousandths of an inch, so it's just slightly over what I got, just bolting the flywheel directly to the crank. So now that the flywheel thing is solved, obviously this J2K needs some block mods for the clearance for the half shaft, especially pretty much half shaft's pretty much in line with this bolt. And all these bolts here go to the main caps from the side. So this one, a bunch of grinding needs to happen here, and I think this one will need to be modified as well, just for axle boot clearance. But what I'm gonna try to do is, I got these Allen bolts in a counter borer, so I'm gonna try to remove this one and that one, and use the counter borer to make a hole that will allow me to get these Allen bolts in there and basically have the top of the head here flush with the block down in here. So I only want to remove the minimal amount of material I can, and like the actual half shaft doesn't need all of this ground out, just like maybe half of it. We'll probably make it work with that, because I don't know if you can see it, but the block, it's adapter, there's actually, yeah, see? So if I actually ground that all the way, there'd actually be a hole here leading into the bell housing area. It appears to have worked, just using the counter bore and the hand drill. So it'll sit about there, and I'll grind this away to be even with the top of this, and hopefully that's enough. I can always keep going deeper, but I want to leave as much strength there in the block as possible. I'm just going to do this one, and this one's only going to go deep enough to have the bolt head flush with right here. Alright, well, this is a carrier for the half shaft, and unfortunately it's just way too tight for the bearing. And if you look at the stock K-Series one, I mean, there's a big difference in the fit. So I'm gonna machine this thing going like this, clean it up or widen it up a little bit. Let's see if it works. Alright, I think that'll work. Drops in most of the way, and you just gotta press it the rest of the way, which is about how the stock one is, so should be good. Okay. Yeah. There it is, got the new seal in. And luckily the snap ring fit and everything, so I just gotta put the half shaft through it. Alright, there's that done. Alright, there it is. Test fit. And it actually almost fits even as it is. So I'm gonna grind this down some. I do want to try to save this hole if possible. Then I'll of course grind down all in here. There's that installed. So I decided to try to fit the axle. Yeah, it just keeps getting better. Yeah. There is clearance, but I don't know, these can flop around a little bit in use. And I think this is probably gonna wind up touching that bolt head. So I think I'm gonna counterboard this hole and just use an Allen there. Okay. So that's okay. I did notice right in here, the boot band kind of rubs on that. So I'm just gonna grind a little bit more off of this thing. Yeah, this thing is close. Clutch is a K-Series Stage 2 competition clutch. This was the last picture of the CRV before I started tearing it apart. Here's some pictures comparing the B20 all-wheel drive to the J2K all-wheel drive. I did weigh them, and the B20 is 442 pounds and the J2K is 469 pounds. But the J2K is missing the starter, alternator, headers, and fluids. So in the end there's probably a 40 to 50 pound difference between the two setups.